And because most of you are probably already wondering, what is a kudu? A kudu is a form of antelope, and the way we came up with the name of the company was actually by writing a predictive algorithm to figure out what was going to be the best name to minimize the cost of SEO and increase the amount of traffic we were going to get to. So nerds at the core, the company started was nerds, and you're going to see there's a lot of that. So before getting started, I think it's always interesting to think about where we've come from to understand where we're going, and that's why I like to look at the AI landscape today. I think it's pretty obvious that at this point AI and machine learning have become a commodity, and the acquisition of Prediction.io by Salesforce was a pretty good indicator that a lot of the bigger players are actually thinking about making this an out-of-the-box ability to run models on top of their platforms. Most of the players out there actually have their own machine learning products. I do think that, however, because of that, we need to stop talking so much about AI, and we have to stop this marketing craze where everything around AI seems amazing, because I think it's going to start hurting the industry, and IBM Watson got pretty hurt, if you guys have been following over the past few months, where when they started working with MD Anderson in the US, they predicted that they were going to help the company cure cancer, and a couple months ago MD Anderson actually pulled out of the IBM implementation because they just couldn't get it to work. And I think this is a pretty strong illustration of how you can generate a lot of marketing buzz around the promise of AI and how it can actually help businesses, but then the reality of execution comes into play and it becomes really hard. And I think that's where Salesforce actually has a really, really solid play, in the sense that the way Einstein has been marketed so far is really as a solution where it has some out-of-the-box capabilities, but really what makes Salesforce and Einstein in the future that much better is actually all of you in this room, right? Because even though on this slide they're only showing native data sources and native applications at the end, the truth of it is that the strong and the core value of Salesforce is actually all the ISVs and the implementation partners who come in and help you capture more data to feed into the platform and actually connect more applications to get more business values out of it. And I think that's really the strong play that's going to help Salesforce be actually one of the winners, where a lot of the others are actually going to have a really hard time. And this is not, it's important to remember this is not something new, and we've already seen this trend in the past 10 years. So having been in data science for about 10 years, it's really interesting to see the similarities in patterns between the big data kind of bubble and the similar one we're seeing with AI. So if you remember a couple of years ago when big data was the massive craze, the media was really focused around volume and velocity types of issues with big data. So those are like the two of the three components of big data. And that made sense because everyone wanted to hear about Google or Facebook and Twitter and how they were dealing with these massive streams of data. But the truth of it is that within the enterprise, the struggle is rarely around massive volumes of data, and it's less around velocity of the data. The real struggle in the enterprise is around the variety of the data, and that's because you're dealing with structured data, unstructured data. Even the structured data is coming from multiple data sources, and you have no common semantics to actually put the data together and be able to run models on top of it. So I think it's extremely relevant to the AI space, where deep learning is another one where it's about exploring massive data sets. There's predictive models that need to be able to compute at a very strong speed to be able to accommodate for streams of data. But again, the core struggle that we're going to see in the enterprise is how do we take the enterprise data, extract value out of it, and then build models that actually will have a business impact. So I think learning from the successes of big data is what's going to help companies be successful in the AI space. So really it's about focusing on feeding the right data to the platform so that it can perform, and focusing on defining some core business cases that we know are going to drive impact. And I think sales is an amazing AI opportunity, because at this point it is fairly untapped as a sector. You look at a lot of the AI that has been commonplace. At this point it's a lot in the information sector, there's a lot in marketing, but there's very little at this point that has really been done successfully in sales. And again, looking at past successes to see what we can do, I think it's really interesting to look at how big data changed the way we actually do marketing, where if we take the history of marketing and we look at how we went through a full loop. Before the Industrial Revolution, essentially marketing and sales was your local baker or your local butcher who was tailoring their offering to you because they knew you as a customer. And then came in the Industrial Revolution, where now we're able to produce products at a massive scale. And then everything became about how do we actually ship these products and how do we get to sell them. The customer was no longer anything else than a means to just get rid of our products that we're able to produce at massive scale. It's very interesting just to look at the marketing tactics, and we talk about the 4 Ps. Everything revolves around the product. I think what big data brought was the ability to actually run the personalization that we had in the early days, but at massive scale. And so that became really interesting because this tool and this data enabled us to really go back to the core fundamentals of marketing by putting the customer at the center of every single initiative. And if we look at sales, we're in a similar pattern, right? We started with field sales where people would come and sell you a product and really tailor the value proposition to what you're doing. They would give you a demo in front of you. And then came Internet 2.0 with the ability to actually buy products online. And now we're at this point where we no longer have field reps and we have inside sales, and you have to fill in these crazy forms to be able to determine if you're qualified or not to then talk to a rep. And I think AI, by being able to predict the quality of a lead very early on, is again something that can disrupt this whole flow to bring us back to something where the customer and the prospect is at the whole center of the process and really make a good experience for the prospect by being more prescriptive and predictive rather than constantly reactive. And so with that in mind, I just wanted to cover a couple examples of how we've actually used our technology to make Einstein smarter. And I think the idea here is really to inspire you to see that there are use cases and there are ways to actually plug into the platform and to make it better. And the first way is just looking at basic lead scoring. And so in this case, what we're looking at is if we're building a model to predict which of the leads are actually more likely to convert to opportunity, fairly standard lead scoring problem. Just for all of you here to remember, this is a regression, so we have a target, which is the conversion of a lead into an opportunity, what we're going to call Y. And then we have a set of predictors. And these predictors are the observations, the known information about the leads. And what we're looking for is correlation between these predictors and the actual outcome. And so the standard way of doing it is really running a model that's going to look at your data and look for patterns in there that correlate different types of information with the lead actually converting to an opportunity. And just for the fun of it, we actually ran that with one of our customer data set. And so we took a customer who's a B2B SaaS company, sells at an ACV around 30K, and we kind of ran a regression the way you would with Salesforce Einstein. So we took a lot of the information that's going to be available in there. So we have what was the number of employees of the company, had they raised any capital, and how much they had raised, their Alexa rank, geography, industry, and we put one fancy feature, which was the tech count, which is the number of technologies they have on their website. And so from that, we ran the standard regression where we split the data in two, run the training on one data set, and then run the prediction against the other to see how well we perform. And so this was the performance. So the top chart is essentially showing you how well the top decels perform. And then the bottom one is telling us that there's a pointer. But essentially what we can see is that line 25 there, we're at close to 80%, which basically means that we can identify the 25% of the population that are going to generate 85% of the total opportunities. So that's a pretty decent model. What was really interesting was to see that we did a lot of overfitting. And for those who don't necessarily know what that means is We're running a regression with a lot of different features in this case, and there are too many to actually fit into the feature space. And so this is a very common problem in data science, that if you have too many elements, too many descriptors of your data, and too few conversion points, when you train your algorithm, it's going to fit every single point uniquely, which means that any new data you bring in is probably going to be off the chart. And so that's a true problem that lots of people are focusing a lot of attention on, and it's not necessarily something that comes out of the box with the Einstein platform. And so what we then decided to do to just prove the point that being able to run regressions is not everything was that we took that data and we derived features out of it to then push it back into the regression. And just, again, some ideas of things that you can do on your side. What we did was we took, for example, zip code. From the zip code, we got the pricing per square foot of office space, and from that we ranked it into deciles in the US. So now we're able to say this company is actually in an office that costs within the top 10% of the US, which is a good indicator of how much budget they have as a company. And so taking just two features, we're actually able to generate 50% increase in our prediction with only two features instead of the 7 that we had before. And so what is really compelling here is understanding that the main issue that people are going to have with running prediction models are not going to be actually training the model and all the operational component of it. It's really about figuring out what data to put into it and how to have a model that actually performs in real life, and not just in a statistical model where your data scientist shows you that it predicts really well in the past and it's just going to be terrible in the future. So the idea behind this is that it's really, really important for you guys who are going to be looking into buying solutions and to implementing Einstein to realize that any kind of brute force algorithm you push into a business problem is never going to compensate for clean data. So the concept of garbage in, garbage out applies just even more in the AI space than ever before. So moving into the second component we were talking about, we were saying that one aspect of working with AI is going to be feeding the right data into it. The second one is finding the right business cases and implementations. So here are just some examples and our own framework that we use with our customers to determine when there's actually AI potential. And so the way we look at it is that we look at any task that is done, and we look at what is the cost of doing this task and what is the leverage of a human being doing that task. And I think it's really important to focus on the fact that we are in a time where it's important to not focus on efficiency but rather leverage. And just to make sure that difference is clear, when we're talking about leverage, it's how can I maximize my output given an input. And efficiency is how do I minimize the input to get to an output. And so it's really, really important to understand that what we're trying to do is not build more efficient humans, is to build humans that have the highest leverage. And so that's why a lot of these tasks that humans are doing today, like classifying the responses of emails that they get when you run an outbound campaign and you get a bunch of responses and you want to figure out, is this, I'm interested, I'm not interested, I want to talk to you later, just unsubscribe. That is a task that has very low leverage for a human being to go and do and just go through their emails and process. And this is typically something that you can easily do with the sentiment analysis or the intent analysis in Einstein, and now you can automatically flag all of this. It's something that has a high cost because your reps are expensive, and it's extremely low leverage for them. So it's a great AI potential. But I think more than that, and what really excites me about Einstein is really that AI is enabling us to get back to connecting people by enabling relevance at scale. And just some examples. So initially, a couple slides ago, I was showing you this horrible demo form to go and contact someone. Today what's really interesting is that we build an onboarding journey for our best prospects that is terrible because they come along with bad prospects. Why do we ask companies to give leads to give us their name, their company size, the technologies they use, only to be able to separate them from the bad leads? But what if, as soon as they gave us an email, we were able to identify if they are good or bad, and therefore not need to ask more questions if we know they're good, so that the good leads actually get a fast lane directly to speak to our AEs. And so these are some examples of things that we've done. This one, for example, could be a combination of Einstein and web form, where when the person starts filling the form, there's only 2 fields required, and if the lead is not qualified, we expand the form to now ask for the additional information to further qualify them. But if the lead is qualified, we're done. Just the email and then push to a rep. Similarly, thinking about the demo forms, one of the experiments we ran was to say if a qualified lead is requesting a demo, instead of then having to send them emails and have them book a time, why not just give them access directly to the calendar of the rep after they submitted the demo form? So that way they're at peak intent, they're requesting a demo, we know that they are actually a qualified lead immediately, now we just give them access to the rep's calendar. And what's really interesting is that beyond the kind of theoretical aspect of this and the fact that it looks good, it actually does have huge results, and it is a fairly low implementation cost. We're not talking about pulling out a huge part of your stack and implementing a new one. Then more things where we played with dynamic home pages by changing the call to action from requesting a demo to signing up for a free trial based on the qualification of the lead. What was interesting is that in both cases we had an increase by 30%. So if the lead was qualified, was a better fit for a self-serve flow, showing them a self-serve button actually increased the conversion rate by 30%. On the flip side, if you had an enterprise customer, showing them a demo request rather than sign up button increased also by 30%. So really it's all about figuring out how you can tailor your onboarding flow for your best customers and your best prospects. And so kind of the 3 things I think I would like you guys to take away from this is that first off, AI has never been easier to implement. And I think Ludo insisted on the fact that it's never been easier to start a company today. That's true, and it's never been easier to have AI as a part of it. So it means that it's never been easier to go and solve some pretty complex problems that are going to be high cost, low leverage, which means that people are going to be interested in solving. So it's very easy to pinpoint small problems and go and fix them. The second component is that I think it's really important also to look at what Einstein is enabling as what people call growth hacking, a lot in the Bay Area at least, and it's breaking down your sales process into small components and figuring out what is the AI potential against each of those and addressing small problems one at a time. I think that's a really compelling way to start showing significant business results from implementing AI. And the final one, and probably the most important, is that as leaders in the industry and as people that are within this circle of Salesforce, we really, really need to understand what AI is. And we really need to be able to decipher the marketing, wishy-washy kind of promises from the actual reality of the execution. And one way to do that is to constantly and consistently focus on the business impact of any implementation of AI. And I think this is probably going to be, as again leaders here, your main challenge across the next few years in understanding where to focus your energy to have the highest impact in this space that is going to be very, very noisy with a lot of marketing information. So on that, thank you very much for being here. If you want to nerd out more, I'll be around, but feel free to contact me or to go to our contact page. And if you are qualified, you will get access to my calendar directly. Don't know if we have time for Q&A.
Do we have time for Q&A?
Yeah.
All right. If you're using just essentially a domain name to filter out qualified leads, how do you believe in the accuracy and integrity of your data? Like, how do you know that domain leads to a qualified lead?
So it's an excellent question. There are 2 components, right? There's the so I guess you're asking about the training of the model. How do we make sure that by training a model on the domain, getting a lead from that domain is still going to have a higher probability to go to opportunity, right?
If you're going to segment so specifically kind of bifurcate immediately on domain name, How do you know that that's a good set? Where does the confidence come from?
So that's an excellent question. And there's a couple things. It goes back to the idea that what you're looking for is not something that is going to solve 100% of your of identifying good versus bad leads. Like I think it was George Box, who was a famous statistician, said, "No model, all models are wrong, but some are useful." And I think that's really important to bear in mind, and that to me really resonates a lot. It's like no model is ever going to be 100% accurate, but the question is, can you make it useful? And the idea is that if you have an obviously qualified lead, give them access to a white glove type onboarding. And then if you figure out in the future that there are other types of leads that actually are extremely valuable to your company but that you had not identified in the past, then that kind of requires for a retraining of the model, but it's something that models typically start picking up. But it's a constant, you're constantly reworking on those models. And that's why you want to make sure that when you're doing this of giving access to the calendar immediately, it doesn't mean that people who don't qualify never get access to the calendar. And that's why you essentially want to run the same process of further qualification to see if that lead is actually qualified. Does that answer your question?
A follow-up, but I'll wait and see.
So including the words like which
Follow-up question. So are you, this is hypothetical or maybe it's not hypothetical, are you doing this in real time? Like I key in a domain and then you're going to go inspect it in real time? Or are you preemptively trying to scrape domains and make some sort of decision?
No, yeah, it's all done in real time.
So, your example you used, like a real estate market with rent prices and that kind of thing. Is that the level of fidelity you're working with? Like, do you find a company, don't look up a DUNS report or something?
Yeah, so we use systems similar to, we don't use DNB just because DNB is a static database, so I mean actually we could plug APIs on top of it, but there's a bunch of API products out there that do the enrichment where you can fire an API call to them and they reply within, usually their SLAs are within like 100 milliseconds, so then you can plug it on top of it. And I think also the idea is that when you look at the zip code is usually a piece of information that's very, very easy to get quickly. And that's why going from zip code to actually budget with these kind of the hack of the office space pricing, that's really interesting because you go from a piece of information that you know you're going to have generally consistently across your entire domain base, and you're able to get at least a good sense of how big the company typically is.
Sorry, just to be clear, I mean that what you're talking about there, that's what you do at Kudu,
Yes.
rather than being something that sits on top of Einstein and Einstein's merit, right?
So yeah, we do that, and then we feed it into. So Einstein basically is a scoring. It's a scoring function. So it's a matter of what data you put into that scoring function to get the output. So we do taking the raw data, extracting some smart features that we can then push into that scoring function.
Okay.
So yeah.
You're basically you're configuring Einstein to use your extrapolated data rather than say the raw data.
Correct. Yep. All right. Well, thank you very much.